Hello, everyone. Welcome to the SafeHouse. I'm Jeff Edwards, co-founder of SafeHouse Initiative and your host for today's podcast. Enjoy. A couple of months ago, I came across Sarah Flukes, and she was advocating and giving away some extremely valuable information, cyber decision diagrams. And it really caught my interest in the fact that, one, she was giving this away, and two, the complexity of it, at least from my eye at the time, I had to talk with her. And so today, Sarah Flukes from Admeritia, who she's the CTO of, has agreed to join us and talk through this whole adventure with us. Sarah, welcome to the Safe House.
Yes, thanks for having me.
It's really good to have you too. So, Sarah, first time on the Safe House. Why don't you introduce yourself to the audience? What's your journey to get to where you are today? Because I'm sure you didn't start as a CTO.
Sure,
Well,
didn't
unless you
know.
did, you're very impressive right out of the gate there. But so, what was your adventure to get to where you are today?
Um, well, depending on where you want me to start, but my background is in engineering, actually. So in
Hmm.
mechanical engineering first, and then I turned to automation engineering. And then when I was about to finish and I had to look for a master's thesis, I had done some of the IT stuff in my master's and a bit of security, and that all sounded interesting. And I thought, okay, but I'm only an automation engineer, so how would they need me in cybersecurity? And
Mm-hmm.
then I turned to the German Federal Office for Information Security, and they had offers for master thesis at the time, saying OT security wasn't the word at that time, but I think it was something like industrial control system security. Um, and they had some kind of master thesis about industrial control system security, and I was first learned that this is actually a thing. So that there's actually like
Yeah.
a subsection of cybersecurity that is about automation systems. The thing that I had just studied, that wasn't not an
Mm.
expert in, but at least I had studied it, and that my expertise could be valuable to cybersecurity. And that's when I started and never left, I guess.
So, an engineer at heart and by trade, and now you're in the cyberspace.
That's right.
Yeah. So, if you could step us back, because what caught my interest, as I said earlier, was you were giving away, not selling or anything else. This whole the diagrams, the cyber decision diagrams. What is the origin of that? How did that all come about?
Well, the origin is actually the first ideas actually do root back to the master thesis that I wrote at that time. So
Oh, okay.
when I started doing that, I realized so the job was and the thesis was to help water utility asset owners, small and
Mm,
mid-sized companies most of the
yeah,
time,
yeah.
um, to do cybersecurity for the first time. So
Mm,
based on German IT Grundschutz, which is like a cybersecurity framework similar to NIST CSF, but from the
mhm,
German Federal Office of Information Security.
mm,
And the idea is that the idea was at that time that you create a profile for these companies and say, okay,
mm,
if your systems look about like this, then
mhm,
a good basis for cybersecurity could look like that. And for that profile, I had to sketch out what systems typically look at,
mm,
at asset
mm,
owners and water utilities. And I talked to really a lot of people, some of whom I still have contact with today. So through contacts of my professor and all that, I reached out to lots of people working in the automation industry and asked them, how do your systems typically look like?
mm,
So like what kind of networks do you have? What kind of systems are in there? What does the architecture look like? And it was the first time when I found that this is really not an easy question to answer because most
yeah.
people haven't really, and there weren't any books about that or anything because most people hadn't really thought about that. And there was never the need to create like one diagram, just simply sketching it out so that a master thesis student could understand. So that's when I back then, based on Microsoft Office and PowerPoint, created these diagrams myself just for this thesis. So this is like the first time when I realized it sounds like an easy question. Just how do your systems look like in principle? Just simple enough to explain to a master's thesis student. But many people don't really have an easy answer to that. I thought I just call someone and they give me a picture that they always use, and then that's done. I thought that would be an easy job, but it wasn't at all. Right? Yeah. And this same insight I had over and over again. Then later, when I joined Admeritia, working with a lot of clients. In water utilities, but also in all kind of other critical infrastructures and chemistry, the chemistry industry and other production sites. There never was, I mean, engineers are used to having drawings for everything.
Yeah.
Really good drawings, but there was never like a good quick explanation, an overview, like a one-page overview over all the cyber systems with the information that you need to do cybersecurity. So that was always lacking. And so that was the first thing that we always created. And after a while, we developed a methodology to do it based on functions, because we realized that if you ask engineers about what kind of assets are in your system and what kind of networks do you have, then mostly the answers don't turn up that great. So,
And why is that? Why is that?
I think because they don't really think in networks and assets. It's simply not. I mean, most of them, they're electrical engineers, they're control engineers, they're process engineers. They're not IT people, so they don't think like IT people. And they don't look at the systems and say, "Oh, look, it's a network," and they don't have network maps in their minds. So they really struggle if you ask them these questions. And we would often get back network plans with like Ethernet patch plans or things like that,
Well,
which of course was not really helpful at the level of detail that we wanted.
is that because in OT they traditionally grew up with closed networks? I mean, they were just their own closed networks, not open to the networks at large. Is that why they didn't think in terms of that? They just took it for granted that the network was just a part of the OT system itself?
The network just didn't play that much of a role, I think.
Yeah.
And many times, I mean, sometimes they didn't even have much of a network. Sometimes it was still some kind of field bus system or something like that. And then if they had, then, I mean, this is back a decade back at least, but I think sometimes it's still like that. And even at least in these smaller water utilities, it was often like there were engineers and there were electricians and people like that, and they had administered the entire control systems. And for the IT was just the job of the one electrical engineer that also, as a hobby, had some servers at home. So more or less. So like, because it was just such a small portion of the overall control system. And of course that there are larger companies that have their own IT departments for automation systems, and also things have changed since then. OT has become a term, and there are OT departments that take care of all the networking in automation. So things may have changed a bit, but still, because it's not that common for IT people to have diagrams like engineers have, these really what I would like, what I call like a cyber diagram, where you just have an overview over your entire plant in a high level with just the information that you need, not to maintain the entire system. You don't need every IP address, but you need enough information to understand what's going on and to secure it. That kind of diagram is still usually not present, and there is also not any kind of standard or anything for that.
Yeah. Well, so you have a methodology that you've developed and you've adapted to, have you adapted it outside the OT, the engineering world into a more of a general cyber, anyone that you talk to beyond, traditional OT managed type systems?
Actually, yes. So one of the core things that we developed we had to find a way, because engineers' time often is very precious. So we had to find a way to really quickly get the information out of these people's heads, to make it accessible for security people and for risk assessments and all kind of stuff. So, and we found that that's where we started off the last point before we derailed a bit, but that's okay. They didn't really get good ideas when we asked them about assets and networks. So we started asking them about functions. So what do you do with all these systems? Like, what is all this technology for? What do you do do with that from day to day? And if you ask them about, well, how do you actually program that PLC, or how does operating and observing work at your site? We got them talking, and they explained, and then we would really put down these kind of functions that also involved different assets, the types of assets, and communications and networks, but also humans interacting with these assets. And we would get them on paper, and in the end have like something between 10 or 50 function drawings. And if you took them all together, you had a pretty good understanding of how these systems worked. And we just did that out of necessity, because we had to find a quick way to get the information from these engineers out there to create some kind of diagram that gave us an overview of what was actually happening at that plant. So that's something that we had done for a long time. First in Visio, which was a pain. Everybody, I think, can understand who work with Visio.
Yeah. I go with you on that. Yeah.
Yeah. So that after some time, we started to create a piece of software simply to get rid of the Visios. And then we quickly discovered that if you have all this information in a piece of software and you've got a database to back it up, then there is incredibly added value compared to just having a Visio, because then suddenly all these diagrams are not just pretty pictures that are readable by humans, but you also have data points that you can attach to all entities in your diagrams and things like that. And you can do risk assessments in there. So these diagrams are like the starting point for everything. Because nowadays, if people do risk assessments, I think it's always such a shame, because there are often network maps or things like that created at the starting point of a risk assessment.
Yeah.
And then people do the risk assessment and they put the network map aside and do the risk assessment in some kind of Excel table or another tool, and then never look at the drawing anymore. So, and this is just a lost chance, because you would be able to get so much more information if you actually worked with that drawing and not just created it because you had to and then put it aside. So, yeah, and that was the idea, was when the idea was born of the cyber decision diagrams, to actually say, well, these diagrams, they have such a high value to the people we work with. So they would often say, okay, we used them for operations. We kept them, these function drawings. So I always like to tell one story where I had an engineer I worked with, and they had an incident. We had done all these function drawings and we had sketched them all out. And then they had an incident in their IT, some kind of ransomware, or I don't know anymore. And the head of IT called him and said, well, we have a problem. We need to quickly remove the connection between IT and OT and pull the plug on the firewall that separates IT and OT. Can we do that? And well, the engineer said, well, in back in the day, before we had these function diagrams, I would have had no idea how to answer that. But now I just pulled out my diagrams and I looked in which of the diagrams this firewall was. So I know that for which kind of functions this firewall would be used. So I could tell him, okay, I know which kind of functions don't work anymore if you pull the plug on the firewall within like 5 minutes. So that was a game changer.
Nice.
And yeah, and that is why people like these diagrams instead, where we actually don't just use them for security, but we also use them beyond for operations. And we would love to have something like that also for designing systems, like in the design process when we make changes to systems, when we make really early architectural decisions, we could draw them up right in the beginning, because we do that for all the other domains. We do that for electrical, we do that for process engineering, but we don't really do that for cyber yet. And we would like to change that.
Yeah, so you could use these for DevSec then for as you develop your upcoming software applications, things of that nature. You could use your diagrams, I assume.
Exactly, right. Yeah. So, and we had a research project at that time, I think the last 3 years or so, a year ago, on security by design. So the research question actually was
Mm.
how to integrate security into the automation engineering process. So when a
Hmm.
big process plant, for example, is engineered, like how can you in this really large, complex, multi-year, multi-man year project that already has so many different domains involved, how can you get
Yeah.
cybersecurity into that? So that was one of the questions that we were pondering. And we always thought, well, we just come up with a pretty flow chart. I don't know. There's a flow chart for engineering. And again, we just ask people how they do it today. We have a pretty flow chart. And then we have an even prettier flow chart that includes cybersecurity. And of course, reality didn't play out at all like that. So
Well,
people didn't have a flow chart and they didn't work as in a flow chart. And if they had a flow chart, it would have been so different for all engineering processes in the world. So yeah.
yeah. So it says
And
cyber decision diagrams. So is there just a standard diagram set that any industry could use potentially, or is there very custom to each type of an industry, like a water processing plant versus a manufacturing facility?
well, the diagrams themselves will be different, but the type of diagram, like the method how you can
Yeah,
create them, is the
yeah.
same for all. And
Okay.
I would also say we've even used them for non-OT processes. So we've even used the same methodology, for example, to model SAP processes in or something like that. So
Yeah.
because
Okay.
people said, well, in the end, you can also ask SAP, like what kind of functions do you fulfill with SAP? You do some billing, you have some billing process, some procurement, and then you can ask, okay, and who does what with which systems, and you can draw these functions. So it works just the same actually in IT. I think the functions are very similar to services that you have in IT.
Sure.
Yeah.
Yeah, since it's
Um,
function oriented, that makes a lot of sense because you're really understanding how the business works or whatever entity is, whatever their business is.
Exactly,
Yeah.
exactly. That's why we have had IT departments asking us if we could do the same thing that we've done in OT because they found it interesting.
Mm,
And we had also people use it for business impact analysis if you want to
mm,
understand how processes
mm,
work, because you can even draw these kind of diagrams if you don't have any cyber asset yet. You can also have like more abstract entities that represent something more abstract than a cyber entity. So I could say, okay, I need some kind of functionality here. I need some kind of system here. And I
yeah.
don't know yet what vendor it is, what kind of system it is, if it's one system or 5 systems, but you can still model it on a very high level very early in the process before you have any details.
Couldn't you
And
do use it for even disaster recovery or incident response? Would it be helpful there?
yeah, one of the examples was the one that I just mentioned. So it is
Yeah.
helpful because what you need in incident response is you need to quickly get an overview over things, how things work
Yeah.
together.
Yeah. Yeah.
And it's also very helpful for example, restart plans. So if you need to know how exactly you want to restart your systems in what order and what depends
Mm.
on what, then it's very helpful to have that just in a high level diagram because it just gives the things some structure that a long list of assets can't.
Yeah. Well, it sounds like you need to have some expertise in which to, execute upon these diagrams, but you decided to, you're giving them away for free. Can you explain the rationale for that and how they can be used by someone who's not educated on using the diagrams and how does that process work?
Well, so I thought, I mean, we do have a commercial tool that's way bigger than the cyber decision diagrams
Mhm.
tool, the small one. But I think the main concept and the main idea that you need to understand for the bigger tool is all in the smaller tool as well. And I
Mm.
wanted something that really helps people understand these basic concepts because I think they're so powerful and you can actually apply them regardless of the tool that you use. So
Mm.
to just play a bit around with the idea of having a function diagram and with the idea of starting with a high consequence event, so starting with business impact, then building your function around that. And the cyber decision diagrams really are just for building, taking one function as an example and one attack scenario as an example, just to get you accustomed to the idea and also to give you a good export that puts everything that you need now on one page, because I also wanted people to see how powerful it is to communicate your cybersecurity ideas and rationales and the reasons why you are recommending some kind of cybersecurity measures to others, to even to non-experts, to auditors or to your management or to externals or whoever who is not deep in your systems and in your systems technology. And I wanted them to see how easy it can be to communicate these ideas if you just use a very basic diagram and if you have a traceable justification for straight from the cybersecurity requirements that you have back to a risk scenario that you may have sketched out, back to a function that is affected by that risk scenario, and back to the business impact that the function actually has. So this is always like the line of argumentation that the whole system follows.
Yeah. I'm sorry, I interrupted you.
No, that's okay.
No, so really it's an effort to create awareness of how powerful a tool that people may not be aware of, these diagrams, how they can be applied to help them improve their cybersecurity overall.
Yeah, and I also found that it's very hard I've spent so much time trying to explain, like I'm doing it here in the podcast, to explain the value of functions like in theory. Without showing people actually what I mean by function, because it's such a broad word and you can't really. And I think you can. I just got frustrated at some point and said, okay, you don't understand it until you see it. And I saw in my customers and the people I worked with that they instantly got the idea when they saw an example. I could do like 1 hour of talking about what a function is in theory and how powerful it is and the stories, how it works and why it is so great to have them and why it helps to visualize them, because a picture is worth 1,000 words. And I could talk on hours and hours and they would say, yeah, makes sense. Yeah, I don't know, but they weren't convinced until I just showed them an example. So I just wanted to have a publicly available example and a way to do it for free and to just learn and understand, because I think if more people understood that concept, we would just be in a better place in cybersecurity.
Yeah, a picture's worth 1,000 words easily, maybe more.
Yeah. Actually, not every picture, and that's also one of the secrets behind the cyber decision diagrams. Well, that's the nerdy part of it, probably. So I'm not going to dive too deeply into that. But a picture is only worth 1,000 words if the humans looking at it can grasp it intuitively.
Yeah.
And there's a scientific term for that is called cognitive effectiveness. So that means you can actually, so images with a high cognitive effectiveness, you can actually understand with your subconsciousness. So that's why they're so much more effective than prose or than text, because you look at that and without you having to think about that, you get some information. That's what makes them so effective. But there's some science around that, and not all pictures have this value. And I think it becomes quite clear if you think about, I don't know if you're familiar with that or if the listeners are familiar with UML, for example, the unified modeling language that many people use for software engineering. That's basically very complex pictures, or take any modeling language used for model-based systems engineering, for example. These are great concepts, but the images that come out of it really are not designed for humans to read them effectively, because they have a lot of blocks, rectangles, black and white rectangles, and a lot of arrows that have different type of tips. And you always need to memorize all these different kind of geometric forms that the tips can have in order to remember what kind of meaning was behind which of these kind of tips. And this is when you need to start thinking about what was this shape about to represent again, then you lose all these
Yeah, the
cognitive
power.
effectiveness.
Yeah.
So, and you lose all the advantages of the diagram. And that's why it's so important to keep this cognitive effectiveness in mind to make this diagram. And there are a few different principles, and we all adhere to them when creating these diagrams, but one of them simply is to not make it too complex.
Well, Sarah, I tell you, the fact that you're giving this, offering these for free, is fabulous, and that you've agreed that the SafeHouse Initiative can offer these through their tools section of the website, and we greatly appreciate that of you and your organization.
Well, absolutely, because I like the idea behind the SafeHouse initiative that you just make things available for free that you think are worth spreading. And that's exactly the same reason why we made this tool available for free, because we were like, okay, this is an idea that is simply more people should know about that. It will make the world a better place. And the
Yeah.
SafeHouse initiative is a great place to act as a multiplier. Yeah.
Well, I've heard you refer to the cyber decision diagrams as the vessel of collective wisdom. So I think I'd rather list it as that. It sounds so much, it sounds wonderful. The vessel of collective wisdom, because it sounds very powerful.
Yeah, and what I mean by collective is it's really think of them as like the one place where you can take that as a basis. You can go with that to your engineers, have
Yeah.
all your engineers pour their wisdom into it, and then you go on and go to your cybersecurity experts, and they pour all their wisdom in it, and it's all in a format that makes it possible to understand the results regardless of your background. So it has some technical some technical depth in there, but even a
Yeah.
manager with no technical background can understand. And it has some cybersecurity information in there, but even an engineer with no cybersecurity background can understand. And that's what I think what's so important about cybersecurity. People have told me, well, everybody says it's so hard to get IT and operations and engineers at the same table and get them talking. And if you put these kind of diagrams in the middle, it actually works out. They actually talk to each other about the right things, and they exchange their knowledge because everybody can contribute something,
Yeah.
and the result is understandable by everyone. And that's the
Yeah.
important effect.
It's a Rosetta Stone of sorts. It speaks to each one because they can understand in their own terms and their own frame of reference. Sounds like.
Yeah. Yeah, that's right. And that's also why they don't have any complicated visualizations in there. You don't have to memorize any kind of icons to understand them. It's not like a complicated language. It's really just boxes and blocks and connectors, and that's it. So it's nothing fancy. It's sometimes I'm even embarrassed by how simple it is. But that's actually on purpose. So it's supposed to be simple. Yeah.
So, Sarah, I always ask our guests if they had one thing to offer, one thing that the audience can do today, excuse me, one thing the audience can do today to improve their cybersecurity, what would that one thing be besides getting the access to these diagrams?
Well, that's a hard question
It is. It
because
is.
that probably depends a lot on where where the audience is, um, which is a very consultant-like answer. But I actually think the best thing you can do for your cybersecurity is step back for a minute and pause and think about if you're really sure you're doing the right things right now.
Yeah.
And if you're unsure, then get back to the basics. So get back to asking the questions of why are we doing all that? What's the kind of business impact? What's the kind of high consequence event we actually need to prevent?
Yeah.
And then build your basic understanding of your systems from there. So as long as you don't have like that, you don't have to draw the cyber decision diagram like I propose, but if you don't have that knowledge, if you don't know how your systems work in principle and how they can contribute to these high consequence events, you have no way of knowing if you're doing the right things.
Yeah. Makes sense. Well, Sarah, I tell you what, you've the fact that you're providing these diagrams for free and this conversation really helps us understand the origins of the diagrams, the power of them to be used as a way for to facilitate communications between the different groups within an organization. You're going to help a lot of people with this podcast and being a guest on it. So I want to thank you on behalf of the SafeHouse Initiative, and everyone that is going to listen to this are going to appreciate you very much. So thank you.
Yeah, that's perfect. And I also want to let everybody know, I know they're definitely not perfect yet. So working on that. They are, maybe that's also important to say, they are somehow limited. That's on purpose because we provided them. We wanted to make sure that there is really no strings attached. So you don't have to provide any contact information or anything. And also none of the data that you input to this diagram tool is sent back to our servers. But that means that the amount of information that can be saved in the browser is kind of limited. So that's also why the tool is kind of limited. So that was like the natural limit that we had because we didn't want to collect any data because obviously it's sensitive data that people maybe put into there. So yeah, but we do have a link to provide feedback and questions and report bugs or anything, and people use that. And I would encourage everybody who runs into a problem or who doesn't understand something to reach out, because we're always trying to get back to that.
That's wonderful, Sarah. Thank you so much for everything.
Thank you for having me and for the conversation.
Oh, you're a pleasure. We'll have you back again as people start to write you on a regular basis saying, I don't understand this, and you're helping them. So I'd love to hear that adventure.
Okay, looking forward.
Okay, that's our episode. We greatly appreciate you joining us and hope it was a wonderful learning experience. I'm your host, Jeff Edwards, and remember, be safe, be resilient, and be kind to each other. For more educational materials, please visit us at safehouseinitiative.org. All materials are free from tracking, promotions, memberships, or fees of any kind. SafeHouse Initiative is an all-volunteer organization.